We're going to go through primary trig ratios. We're going to talk about how to set up a triangle using these. Now, first of all, our primary trig ratios are known as sine, cosine, and tangent. A lot of the times, people refer to them as SOHCAHTOA. And that is a little acronym to help you remember what the ratios are. Okay. We'll go through exactly why they've talked about them this way. So what this says is sine theta. Theta represents an angle in a specific type of triangle. What type of triangle will this only work for? Anyone know?
Right angle.
It'll only work for right angle triangles. Okay? It can be scalene, equilateral, isosceles, but it has to be right angle. Okay? So what it says is sine of some angle is equal to the opposite side divided by the hypotenuse. So in this case, here's our angle. The opposite side would be this, the one side that's not touching the angle, and the hypotenuse will be opposite of the right angle. I've color-coded it so it's easy to see. And that's why they call the very first one SO. So that sine is equal to opposite over hypotenuse. Okay? The second one, cosine, is equal to the adjacent over hypotenuse. Adjacent means to be touching. Now, technically of the angle, there are two sides touching it. But because this side, the hypotenuse, will always be the longest, it will always be called the hypotenuse. So we refer to the other side touching the angle as the adjacent. So the adjacent side divided by the hypotenuse is equal to cos of that angle, or cos theta. And since why they got cosine equals adjacent over hypotenuse. And finally, tangent. Tangent theta, same idea. We're looking for this angle specifically. It is equal to the opposite side divided by the adjacent side. And then that is TOA. Tan is opposite over adjacent. Okay, so this acronym is to help you remember how to set up these three primary ratios. And what we have to do is actually figure out how to use them properly. So we have a question here, and all they've given us is this side is 5, and this angle is 60. They want us to solve the entire triangle. Okay? So, in reference to this angle, we have an opposite, a hypotenuse, and an adjacent. Which side do we have a measurement of? Adjacent. So this is our adjacent side. Okay. So we have that angle. Let's look at our three primary trig ratios. We have sine theta is equal to, I'm just going to put O over H. Cosine theta is equal to A over H. And tangent theta is equal to O over A. Now, what did we say we have a measurement of? Adjacent. So there's only an adjacent in two of the ratios. Okay? In other words, what that means is we really can't use sine. We do have our angle. What is our angle in this case? 60, that's right. So we can replace this theta with 60 in each of these questions. Okay? But in order to use these, we need to have only one missing variable. In sine, we're missing the opposite and the hypotenuse. So this ratio will be no good for solving anything on this triangle. In cosine, we have an angle and we have the adjacent. So we can solve for the hypotenuse using cosine. And in tangent, we have the angle and the adjacent, so we can solve for the opposite. Because they just said solve the triangle, I can start with either of these, because I eventually have to solve both sides. Okay? So we'll start with cosine. Cos 60 is equal to adjacent, which is 5, over our hypotenuse. I'm going to put that in green. Okay, remember the hypotenuse is always the opposite of the 90-degree angle. So here's our hypotenuse. Thank you. So, in order to solve this, I need to get the variable by itself. So let's think of this as a fraction and maybe another equivalent fraction. The fastest way to do this, who knows how we could get the h by itself? Okay. Yes, cross multiply. That's exactly what I want you to think of. If these are two fractions, the fastest way to get equivalent fractions to be not fractions is to cross multiply. So, on the one side, we're going to have h multiplied by cos 60 is equal to, and if I turn this into 1, it becomes 1 times 5. Right? Well, 1 times 5 will be just 5. And we still have h times cos 60. The goal is to get what by itself? H. Okay. So what's the next thing I need to move? cos 60. Now, some of you might just decide to equate that in a calculator, and it'll give you a large decimal, but we can move it in this form if we want. If we move it to the other side, what do we have to do? Not negative. Divide, because technically this is multiplied by. So it now becomes 5 divided by cos 60. Okay? So h is equal to, h being our hypotenuse, is equal to 5 divided by cos 60. So let's actually equate that in a calculator. Okay? Now my calculator is probably a little different than yours. I have to type the numbers in first and then hit cos. So 0.5. So this will be 5 divided by 0.5. So I'm going to type that in again because I don't have a 2-digit calculator here. 5 divided by 0.5 is 10. So our hypotenuse in this case is 10. So we can go back up to the top. And we know that this side of the triangle is equal to 10. Okay, so we've used cos to help us solve a side. Let's go with tangent now. Yeah? Tangent. So, tangent 60 is equal to, the opposite is something we still don't know, right? So here's our opposite side. So we're going to be looking for that. And our adjacent side was 5. Now this one will be much quicker to find. That O stands for opposite. So I'll put OP so it doesn't look like a 0. We need to get OP by itself. It's opposite. So we really just move 5 to the other side. In order to do that, what does it become? Multiplied by. Right? So this one's very quick. 5 times tangent 60 is equal to the opposite side. And we can again do that in our calculator. So our O, or opposite side, is equal to, whoops, wrong one, 60 tangent times 5, 8.66. Okay? So our opposite side in this case is 8.66. Now there would be a really quick way to solve this, but I want to work with sine, and I want to show you how to solve for an angle in this case. Okay? So now I have 3 sides of the triangle. I want to find this angle here. I'll denote it as a red theta. Okay? So this is our red theta we're trying to find. I do have an opposite and a hypotenuse. Okay? The red theta I don't know, so we're going to set that up with a sine ratio here. So sine, and that's the red theta, so the other angle we didn't know, is equal to opposite over hypotenuse. Well, in this case, our opposite is, what is our opposite of the red angle? 5. It's actually 5, right? It completely depends on what angle we're talking about. So before this 60, that was the opposite. But now that we're talking about this angle, 86.6 is no longer the opposite side. Yes, it becomes the adjacent. So it's always in reference to what angle. So the new opposite of that angle is actually 5. And the hypotenuse is 10. The hypotenuse won't change, but your adjacent and your opposite will, depending on what angle we're talking about. So in this case, the opposite is 5. Sine theta is equal to 5 over 10. 5 over 10 is just going to be 0.5. I'll put it as a decimal because I'm sure you're used to that. But the problem is we're trying to solve for just theta here, not sine theta. So think of it like this. We need to bring this sine. Now, technically, sine stands for a very in-depth equation that we put a number into. Okay? If we were to move sine to the other side, you could say that we divide by sine. But if you try doing that on your calculator, you get an error. Okay? Now, we haven't gone too far into exponents, but technically, to make an exponent come above a fraction, we do the inverse of it. That's right. So what it would become is the inverse of sine to this number, okay? And you'll have a second function on your calculator. So when we bring this sine to the other side, it becomes theta is equal to sine inverse of that value. So you'll have to put inverse of sine to solve this, okay? So theta, or angle, is equal to, and on my calculator, let's see,
30.
I think this is inverse. Nope, that's the wrong one. Is it 30?
Yeah.
Okay, I do want to show you how to do this stuff. There we go. Inverse, sine inverse of 0.5. Oh, I pushed the wrong button. There we go. It's 30. Perfect. So our angle, in this case, or our red angle, was 30 degrees. Now, just before we close that out, there are actually, once we had a bit of information, we could have done this much faster using a couple other things. First of all, if this is 60 and we know this is 90, how can I have quickly found this 30?
Has to be equal 180.
Has to equal 180, so we could have just subtracted 90 and 60 from 180. Sorry, that's 30. And we would have got 30. Okay? We know all triangles have to add up to 180. And once we had two sides of the triangle, we could have used Pythagorean to solve the other side much faster. But I just wanted to go through showing you each of the ratios and how to solve an angle in comparison to a side. Okay, the last thing we have to talk about is angle of elevation and angle of depression. First of all, they'll always be in reference to a horizontal line. So this is our horizontal line. Okay? And from a horizontal line, you can make two angles. You can make one going up, okay? Or you can make one, and I'll change the color for us, going down. Okay? From the horizontal line, the angle going up would be called what? Anyone know?
Elevation.
Angle of elevation. Makes sense. Elevation is to go up. So angle elevation. And then the angle going down from that horizontal line would be the angle of depression, to go down, or to crush. Okay? So that's angle of elevation and angle of depression. Simple as that. Always has to be done from a horizontal line. And that's everything we've done.
Mitchell,